Hello, everyone, and happy winter solstice. And welcome to the December online viewing session for the Kalamazoo Astronomical Society. My name is Richard Bell. I am the president of the Kalamazoo Astronomical Society, and as almost usual, I will be your host for this evening. So, um, of course, it's a perfect day for online viewing session again from Michigan. It's very cloudy and cold. We haven't seen the stars really well for probably about 2 months now or so. So that's why we do these online viewing sessions. I mean, we would love to be outside observing the sky, but we can't because it's very, very cloudy. So thank goodness we have the remote telescope at Arizona Sky Village. So without further ado, let's jump right into it. All right. So here's our title slide, and another new one here, courtesy of Mike Patton. And this is Piishi Observatory. So if this is your first time joining us, we'll tell you just a little bit about the observatory real quick. Those of you that have joined us before have heard this at least once or probably several times. But Piishi Observatory is a 20 by 20 roll-off roof observatory. And here it is. It's located at Arizona Sky Village, which is right near the little hamlet or I don't know town of Portal, Arizona. I don't know if you can even call it a town, maybe a village or I don't know. It's not much, which is good. So you can just see the remote telescope sticking up there. There it is there. This is the 20-inch, which we'll meet later. This is the Takahashi. And you can see we got some stuff on the back there. We have our weather system. And I'm not going to switch the screens here, but let me give you a weather update out there. It is clear, as we'll soon see. The ambient temperature is 54.7 degrees, which is more than double what we currently have here in Kalamazoo, Michigan. The wind is only 2.1 miles per hour, so the wind won't be a factor. If you've joined us before or had to suffer through a postponement, it's usually because of the wind, not the clouds out there. But it's very light. The wind hasn't been much of a factor at all so far this season. And the humidity is only 23%, which also just makes me very sad. It's never that low here in Michigan. We're lucky if it's like 50 at night, but usually it's like, 80%, 90% at night. And when you're done observing, you come home soaking wet. So that's the way that it goes. So that's just a quick weather report from the weather station there. And you can see nearby is our all sky camera there. So this is our Piishi all sky camera that we just recently updated. We now use a ZWO ASI 183 MC color camera, coupled with a Fujinon 2.7 millimeter f1.8 fisheye lens, which gives pretty decent views. So let's go ahead and switch to the all sky camera and see what the weather's like out there. The last time I looked, it was pretty light out, so I didn't see any stars at all. That's the ACP screen there, but there we go. Now we got some stars popping out there. We still need to tinker with the processing of the image, and one of our members recently installed this little barrier around the edge, which doesn't really help at all. He was hoping maybe it would block stray light, but the issues with stray light are more from the sun and the moon. The buildings and what limited buildings we have weren't really in the way at all. So maybe we'll get rid of this eventually. But it does focus your attention on the sky, I suppose. But it's nice to see some of the buildings around the scene there. So even though today is the winter solstice, the first day of winter, we still have the summer triangle here. So we got Vega, Deneb, and Altair. And of course, Vega's part of the constellation Lyra, which is getting pretty low there. It's a little isosceles triangle on a parallelogram. Deneb is the tail of Cygnus the Swan. So there's the tail here. The head's there, the very popular double star Albireo. not a true binary, but a very popular double star. And then we have the two stars here that form the Northern Cross. But these are the wings of the swan. It kind of goes from this star here, Satyr, out to these stars here for the wing, and then out to this star here for the other wing. So the swan's kind of flying toward the horizon there, which you currently can't see behind the screen there. And then we have Altair, which is part of Aquila the eagle, and you can still see the triangular body there, although we're about ready to lose the bottom of the body there. The tail feathers is set, and there's kind of a wing here and a wing there. So we are losing those stars of summer, which makes perfect sense. Then we switch over to the asterism of fall, which is now just passed. And we have the Great Square of Pegasus, the featured asterism of autumn or fall. These three stars belong to Pegasus, of course. This is the back of the horse, the flying horse. It's upside down. So the back is here. You can imagine a wing. Oop, it just reloaded there. The wing kind of comes out imaginary here. There's no stars that show the wing, but there's an upside down head with the star Enif at the snout. There's kind of a leg going out from here, another leg here, and this is the, I guess, horse's tummy. But then this star, Alpheratz, this is actually the head of Andromeda, which is two arcs of stars, kind of one, two, three, and then one faint one there, then one there, one there. So the top arc's a little fainter than the bottom arc, and you can see a faint glow right there. That's actually the Andromeda galaxy that we looked at last month. And then kind of down in this region, we have Aries the ram. I can't quite make out Triangulum. I'm sure it's there somewhere, but this is definitely Aries. And you can just see this is the planet Jupiter. It looks like it's about ready to be eaten by the Hyades, kind of like a Pac-Man eating the dot there. But this is, in fact, the cluster, the Hyades, not the Pac-Man. And then we have the star Aldebaran, which looks like it's part of the Hyades, but it's actually further off in the distance. The Hyades is one of the nearest star clusters. And then we have the Pleiades, which we will be checking out up close tonight with the Takahashi. And we do have another star of winter, because our constellation of winter, Taurus is our first constellation of winter. By the way, the bull kind of goes back in a line of stars like this, or sometimes you can get like a foot here, another foot there, and this is his face. But up here we have Auriga, the charioteer, this kind of house-shaped constellation with the star Capella, and this little triangle here are the goat stars. And then moving back, we can see Cassiopeia here. Just kind of follow the Milky Way through the summer triangle. That leads it right to Cassiopeia. And kind of between Auriga here and Cassiopeia, we have the constellation Perseus. And we'll be checking out another target later, actually at the end of the night, right around here. So if you know your stars or can grab a star map, you can kind of guess and see what it's going to be, but it's right around here somewhere. So that's where we're going to spend some of our time tonight, over in Perseus. And you can't quite make it out yet, but Orion should be just popping up above the horizon there now. Oh, and you might wonder what this gadget here is. If you've never joined us before, this is a bird perch that keeps birds from pooping on our dome, because that was a big problem when we first put the all-sky camera in, is they couldn't contain themselves. And so we thought the bird perch would prevent that, and it really has for the most part. So there we go. There's the current sky. All right. So, as always, our first telescope that we're going to use tonight is our Takahashi FSQ 106 EDX3. And it's basically a 4-inch refracting telescope. Instead of the stock focuser, last year we installed a Moonlight Nightcrawler 2 focuser, because we feared the camera and the filter wheel was a little too heavy for the stock focuser. For some folks it is, and for us, I don't know if it made a huge difference, but it's a really, really, really excellent focuser. So this is the scope we'll be starting with tonight. And the camera that we use on both telescopes, two different cameras obviously, is an SBIG STX 16803 full frame CCD camera. And this is a really full frame camera. Your standard full frame camera is usually 36 by 24, but this thing is nearly 37 millimeters square. So it's a big chip. And it is a CCD. They're becoming kind of like film before them. They're becoming pretty obsolete, and we may eventually upgrade to a CMOS camera probably next year, if anything. Definitely not this year, but um, unless Santa, gives us a nice full frame camera, but that would be strange. But we're looking to maybe upgrade the cameras next year. And before we do our first target, let me go back to the browser here, and we'll click on this tab here. And there is a live view from inside the observatory. So you can see the remote telescope here. This is our mount that we'll talk about later. This is the 20-inch, and there's the Takahashi right there. You can see the flip flat is open. This is like the electronic cover to the telescope. So it is open, so it is ready to go. And you can see some other telescopes that belong to Mike Patton, the member that owns the observatory. He just recently installed this telescope here, a 4-inch refractor, very similar to the Takahashi, just from a different manufacturer. And it's on a plane wave L350 mount. Very nice mount. And he has another one over here. And you can see it's currently unoccupied. I don't know what he has planned there. Maybe he'll tell us later, but you can see the telescope that he had. Whoop, that's too far. It's a sensitive little camera. The telescope that he had on there is sitting there on the ground. So he might want to throw a cover on that. I would. It gets dusty in there, as we know. So, and the other telescope, you can kind of see it pointing right at it. It looks like it's really white there, but that's actually a black cap that looks white in the infrared there. And that's his Coronado telescope. And just inside there is the warm room, or the control room, really. And I do believe we have a couple of members joining us there from the cold room tonight, or the warm room, whichever it is tonight. But that's inside the observatory. We'll check on there from time to time. But for now, we're going to turn off the infrared camera. Oh, there's Tim. Oh, there they are. And so we're going to turn off the infrared camera there so it doesn't mess up any of our images. And then we're going to begin with our first image of the night. In fact, while I'm here, and I can get the zoom controls out of the way. Go away, zoom controls. I'm going to just enter. I have it entered in now. I'm just going to hit it just to make sure. And we're going to hit acquire image and just let it go. And we'll come back to this screen and talk about this screen here shortly. So our first target of the night, it wasn't one I was going to do. No, this was but this wasn't going to be our first target. I was going to do something over in Cygnus, but it's getting a little low to do that now. And the images were turning out okay, but it is getting too low to do. So I decided to rearrange things, and this will be our first target of the night. So it's called IC, or Index Catalog 1805, the Heart Nebula. And you can see, I don't know, I really need to check on the magnitude there. That can't be terribly accurate, but that's what I have, but that can't be right. So I need to check that. And this thing is really big. You can see it's 150 by 150 arc minutes. Just remember, there's 60 arc minutes in a full degree, so we're talking something over 2 degrees in size. So this is definitely a job for the Takahashi. And the distance is correct. It's about 7,500 light years away. And so the Heart Nebula was discovered by William Herschel on November 3rd, 1787. And technically, IC 1805 is classified as an open cluster, but it is also associated with a diffuse emission nebula cataloged as Westerhout 4. But Westerhout 4 isn't, I guess, quite as fun as IC 1805. And it's also cataloged as Sharpless 2-190 from the Sharpless catalog of diffuse nebulae. And of course, as you might have guessed, the name describes how the nebula looks in wide field images, but not visually. Uh, you can see this one visually, which is why the magnitude, or at least through a telescope or binoculars, which is why the magnitude 18.3 is bogus. I need to fix that. But so it is technically a visual object. You can observe it, but by and large, this is much better known as a astrophotographer's target. And we're going to be taking a 10-minute shot of this in a hydrogen alpha filter where it looks quite spectacular. So it's also known as the running dog nebula because that's what you see when you do look through large telescope. It looks like a pair of running dogs, I guess. So if you're curious where it is, it's actually pretty easy to find right on the more oblique side of Cassiopeia. You have the steep side here. This is more of the oblique side of the W, or I guess M now, seeing we see it upside down. And here we see the Heart Nebula, and next door is the Soul Nebula because you have the heart and the soul. But we did the Soul Nebula last year, and I tend to alternate from year to year. One year we do the soul, one year we do the heart, and this is a heart year, so here we go. So that's its general location in the sky, and don't ask me to find Camelopardalis in the real sky because it is really hard. But Cassiopeia is easy enough to find, so this thing's pretty easy to track down if you ever want to take a picture of it or try to observe it through a telescope, at least from a dark site. So here's our more detailed chart, courtesy of Sky and Telescope's Pocket Sky Atlas, which I highly recommend. It's probably too late to get one as a Christmas gift, but it is a great guide to have. Sky and Telescope's Jumbo Pocket Sky Atlas, to be exact. They have a smaller version, but the Jumbo version is the one that I get this image from. So here's, I think, part of Cassiopeia. No, this isn't. Or is it? I can't tell. But we do have the tip of Perseus here. That's another guide to find this thing. And there we see it. It does look more like an actual heart in the image here, like an actual human heart, as opposed to your Valentine Day heart. But it's basically located 5 degrees east-southeast of Epsilon Cassiopeiae, okay, so this is Cassiopeia, because there's Epsilon right there. So this star is also known as Segan, or you can say it's 4.6 degrees north-northeast of the double cluster, the much more famous double cluster just across the border here in Perseus. So Westerhout 5, or IC 1848, the Soul Nebula, is located 2.5 degrees to the southwest, and together they form the Heart and the Soul nebula complex there. All right, so let's go back to ACP and see how we're doing there. So it looks like we are guiding, and let's go back in the log here because I want to check something. Aha! So it's solved, because if you joined us last month, we were having tons and tons of issues with plate solving. And I thought we fixed those issues like a week ago, but we did not. We still had issues, and we made a few corrections today. And it's been working much, 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 much better tonight. So I think we finally have that issue solved. So it should be perfectly centered this time, unlike some of the targets we did with the Takahashi last month. I mean, they were still in the field of view, but just not as perfectly centered as we preferred. But it did plate solving for the focus routine earlier, which it never did. And now it plate solved now, and we're guiding. It looks pretty smooth. And so we are good to go. So let me change the zoom setting here so everyone can unmute themselves. I don't know how to do that here. Let me just I'm just going to stop sharing for a second because it's easier to find that way. And there we go. Participants can unmute themselves. So we do have a long exposure underway. We're not even halfway through. So if anyone has any questions or comments or just, wants to say hi, and we love to have a much more interactive session as opposed to have everyone muted and not doing anything. So welcome.
Hi, Richard.
Hi, George. Welcome.
Okay,
You're
back
joining
again.
us. You're joining us from the UK, correct?
Yeah, in southeast in Kent.
Wonderful.
Gra- Grayford Manor House Astronomical Society, Dartford.
Fantastic. See, we got
And
people from all over the world joining us.
some of them are like me, probably past their bedtime.
I can imagine. It's 8:53 here, Eastern Standard Time.
Hey,
Yeah,
Richard, it's Dave.
Hey, Dave, how are you?
We're great. I'm really enjoying your show so far. I
yeah.
enjoy these very much.
Excellent. We love doing them.
Hey, Richard.
Hello, Richard. I believe I changed your name earlier. Let me, there we go. I gave you the ability to rename yourself. So, uh, Richard Bell, if you want to change your name to your real name, I think that might not confuse people too much because, you know,
Yeah,
this this stream isn't big enough for two Richard Bells. I mean, that's just crazy.
this is Kevin up in Maine, and I'm not sure how to do that. I'm not very good at these computers.
Let me see if
So,
I can. Here, I'll just change it to Kevin. There we go.
oh, great. Thank
There we
you.
go. That's better.
I do have a question.
Sure.
Um, Last observing session, I went over to the site where you put all the photographs, and I kept getting it sent back to me saying that the site was missing. I keyed it in, and I don't know if I did something wrong or, but I was not able to access those photographs.
Okay. Let me put the link in there for last month. I'll just change the one for this month that I was going to give later. So let me throw that in the chat here real quick. I believe this will work.
I experienced the same thing with those.
All right.
I didn't. I got them straight away and did a bit of colouring on them and sent them
Oh,
back to you.
I think I got a space in there. Ah, dang it.
Ah,
That's not going to work either. It looks like there's a space in there. I don't know how that space got in there.
well, that's what we're about, isn't it?
Uh, oh, come on. I'm working on it. Let's try that again. See if that works. That still looks bad. Well, it's like that, but no space in there. Every time I paste it in, it automatically turns it into the link that it was before, but or I can try it this way. Here, I'll change it in Notepad, and then I'll paste it in. That'll work. Zoom's trying to be helpful, but it's not helpful. Okay, one more time. All right, if that doesn't work, I will eat a bug. that, that should work.
Okay.
All right.
Thank you.
Any other questions or comments or anything?
Yeah, Richard, this is
Hey, George.
Hi, George Drake here. I looked up the apparent magnitude of this object in Wikipedia, and it does say 18.3.
I know that's where I got it from.
I wondered.
But I was just busy setting it up, and I didn't think about it, and I'm like, that can't be right. That just isn't right.
Not if you can see it through binoculars.
That's true. Oh, I gotta let some people in here. And by the way, if you are joining us on YouTube, I will try to monitor the YouTube stream here tonight because I do believe we had some questions on YouTube last month that I missed. So apologies for that. And so we do have a handful of people on there, but to be perfectly honest, I consider the YouTube stream more as a courtesy, and I don't usually pay terribly close attention to it. But this month I will try to amend that policy. So welcome to everyone on YouTube, which they won't hear this for another 30 seconds because they're like way behind us. they're in the past.
Hi, Richard. It's Martha Testa from Massachusetts. I haven't seen you in a long time since the height of the pandemic when I took your class, but it's great to be back and to see everyone on the shortest day of the year. And I wish everyone a happy winter solstice.
Well, great, Martha. Thank you very much. I'm glad you could join us again. Let's check in on ACP here and see how we're doing. So if you've joined us before, you know what ACP is. So, but if you're new, let me explain this. This is ACP, the ACP web interface, and ACP, or the Astronomer's Control Panel, is what we use to control the remote telescope. So any member that uses the remote telescope doesn't have to have fancy software on their computer. All you need is an ordinary web browser, and the web interface allows you to connect to the remote computer via ACP to control the telescope. And ACP itself controls Maxim DL, which controls the camera and the autoguider, and it also controls the Sky X, which controls the mount, which in turn points the telescope to different parts of the sky. So we've completed our exposure. And for some reason on ACP here, it always goes 1 or more seconds past the exposure time, but it doesn't actually do that because Maxim doesn't show that, but for some reason ACP does that. And first we'll get a thumbnail here because, you know, the data has to download from the camera. Then Maxim does a quick processing for a thumbnail, and then it processes the larger image, and it also does a plate solving. And right now it's counting stars. You can see the plate solve final image counted 16,644 image stars found, and it'll look for about 400 of those to do a final plate solving. I don't know why it does it at the end, maybe to store the actual coordinates in the image, but so if anyone knows, you know, there we go. Yeah, so about 367 stars have counted. So let's go ahead and check out our first image of the night. So as always, unmute yourself because we like to hear the natural reaction of everyone that sees the image for the first time. Are we ready? Here we go.
Wow, beautiful.
What's that? Like a ghost. Oh, standing on its head.
Super, Richard.
Looks like a mouth of an alligator open.
Don't get too many of those around here.
I think George Drake can tell us if somebody had a heart like this, George, they would need immediate surgery, wouldn't they?
Yeah, I think so.
Extra big lobe there.
Yeah, doesn't look very symmetrical.
No,
You could call it an open heart.
that's true. The open heart nebula. I like that better.
Well, Richard, can you explain? I'm new here and actually at Lake Orion, Michigan, so not too far from you. Is this just a luminance filter or what else is recorded here?
No, this is a 10-minute image with the hydrogen alpha filter.
Okay, excellent. Thank you.
Which really brings out the cloud a lot better. So let me tell you a little bit about this image, or the object more specifically. The Heart Nebula is located in the Perseus arm of the galaxy. So it's the next arm outward. We are in the Orion arm, and the Perseus arm is the next one outwards. Given the distance and angular diameter of this object that we mentioned earlier, and I don't remember off the top of my head, it's roughly 330 light years in diameter, maybe along the long axis here, I'm not really sure. The brightest part of the nebula, which is most likely here, not on the western edge, is separately classified as NGC 896 because being the brightest, it was the first discovered. And there's a small open cluster known as Malo 15 that illuminates the nebula, and you can kind of get a sense that there is a cluster at the heart of the nebula here, or at least maybe the brightest portion. So it's a loose collection of 60 visible stars in a region about 20 arc minutes across. So yes, I believe I am referring to the bright knot there. And the cluster contains very young blue hot supergiant stars about 1.5 million years old. In a 12 to 14 inch telescope with a UHC filter, or ultra high contrast, or your standard variety narrowband filter, it is very faint. The most obvious part is a dim 30 arc minute long streamer south of Malo 15. In a 16 to 18 inch telescope, it is an extensive circular hazy glow. So to really bring out the shape that gives it its name, you really got to take a picture of it. So that's one of the things we like to do with online viewing sessions, is look at stuff you normally can't even look at outside. We make some exceptions here and there, like with the Pleiades later, but this is one that's best to really take a picture of it like this. And don't forget, this is like fresh from the telescope. This is not a stored image. We just took it. So it's live. Any other questions about the Heart Nebula? I can check in the chat there, see if we have anything there. Okay, so someone says Telescopius listed as magnitude 6.5, which seems a lot more reasonable. I mean, being as big as it is, it's going to have a low surface brightness. So yeah, my guess would be somewhere between 6.5 and 8 as well. So yep, that sounds very reasonable. So if I remember, I'll get rid of that 18.5 magnitude, because I don't care what Wikipedia says. That's wrong. That's just absolutely wrong. All right, so we'll go ahead and close this image, but don't forget, I will later download these, give them a little processing, and then you can download this image and all the others tonight, and you can even zoom in for a higher resolution look, because this is a bit, this is greatly reduced, so you can zoom in and see even more detail later. All righty. So let's go to our next target, which I will enter in here before we move on, so we can get going there. So we're going to do NGC 1499. And there's the coordinates. We're going to do the exact same thing. We're going to do a 10-minute exposure with the hydrogen alpha filter. So we'll hit acquire image, and off we go. And you can see it starting to work in the background there, but as it does its thing, we'll talk about it a little bit. So NGC 1499 is the California nebula. So if you are in California, this is your personal deep sky object. And so the coordinates tell us that it is in the constellation Perseus. The magnitude 6, that's very comparable, I think, to what the Heart Nebula actually is, because this thing is notoriously difficult to see. And very much like the Heart Nebula, this thing is big. It's very long, but not terribly wide, unlike California itself. And it's about 1,000 light years away. And like with the Heart Nebula, it is also a sharpless object. In fact, it's sharpless 220, or SH2-220, in the sharpless catalog of emission nebulae. This one was discovered by E. Barnard, Edward Emerson Barnard, in 1884. And by coincidence, it transits the zenith in central California as a latitude matches the declination of the object. So if you are roughly 36 degrees latitude in California, there's a certain time of the year where the declination of this object matches your latitude. Or, it always does, of course, but there you go. So 160 arc minutes is about 2.5 degrees long, which again makes the surface brightness of this object very low and really difficult to observe. So it is a much better target to image or to do for kind of your EAA session like this, your electronically assisted astronomy, which is really what online viewing sessions are. And you can hear the program look for a guide star in the background, so it's working on that. So if you do want to try to observe this, it does help to have dark skies, and it's best observed with a hydrogen beta filter. A lot of people might have a hydrogen alpha filter for nighttime imaging of nebulae like we're doing now, but for visual use, it's better to have a hydrogen beta filter, which not a lot of people have because really they're not good for much. So the Night Sky Observer's Guides only gives it 1 star. It's a really cool object to image, but it only gets 1 star in the ranking because even through a big 12 or 14-inch telescope, it's described as exceptionally large, extremely faint, 3 by 1 arc minute, arc elongated east-west and concave to the south. The O3 filter does little to enhance the view, and several low surface brightness streaks are just visible. So even through a 14-inch telescope, it's not a great visual sight, but as you'll see with the talk, in a good 10-minute exposure, it's quite spectacular. So here we are back in the constellation Perseus. We looked at the Heart Nebula right there. So now we've moved kind of down the wishbone here because Perseus looks like a wishbone. And it's on the long side of the wishbone, just off the star Zeta Persei. So it's actually located about 1 degree north of Xi Persei or Menkeb here. So if you do want to try to find it visually, it's not hard to locate. There's a really great star hopping star nearby, but it is, again, very, very difficult to find. So let's go back to ACP, see how we're doing. Check on our progress there. We got a guide star. We're guiding, and just make sure again. Oh, yep, solved. Although even before we had our issues earlier this week, I was always able to solve for this one. For some reason, it was working on some objects and not others, and this is one of the ones that it worked on. I wasn't going to do this object. I was going to do one, as I mentioned, down in Cygnus, but it's getting pretty low, and I figured we better work a little bit higher. But so if you joined us this time last year, yep, this is a repeat from last year too. But there are just some objects you got to do all the time, and this is a pretty good one. Let's see how the sky's doing. Oh, Venus is now peeked out from behind the bird perch. I believe we were missing that earlier because the bird perch was blocking the view, but there's Venus. We're going to lose it behind the screen there. But now we've made some progress with Orion. You can see the 3 stars in a row and the 2 above and at least 1 below. We're still missing Safe.
Nice.
Yeah, but we have Betelgeuse and Bellatrix and Rigel. So no Safe, S-A-I-P-H. And we got some stars, I think, maybe Gemini? Not quite sure yet. That should be Gemini. But we're looking right about here. You know, I can almost convince myself I can see it. See that little funny glow there? Here, let's pop it out here. We'll look at the raw image. Whoa. No, I guess not. I can't really, it should be right about here. It does look a little red there, doesn't it? I think that's just noise. Oh, see what we got in the chat there. Okay. So we're guiding along there. So it's times like this we, or at least I need help filling time because I'm currently out of material until we get the exposure done. So again, we welcome any more questions, comments. Tell us where you're from. This being our last event of the year, anybody want to share their highlight of the year? I mean, obviously for me and probably for a lot of you, it was the eclipse in April. But we had lots of bright aurora, pretty decent comet. So for astronomy, it's been a pretty good year.
Definitely the eclipse.
Yeah.
What was interesting for me is I followed the NASA sites, 10 of them, and I got 10 images of the total eclipse in sequence all the way up the path. Never done that before.
Nice.
Huh.
At different stages of the eclipse movement. It was really tremendous. And a lot of the sites had their site name on it as well, and the state. So for me, that was quite useful. Just track it all the way up from New Mexico to out into Canada.
Yep. I was in Maine. As many members here know, I was going to lead a group of members in Texas, but I bailed on them and went to Maine, which ironically had the best weather in the nation. That day was completely backwards for weather, but Maine was great. You can watch my 40+ minute report on our YouTube channel. Other members have reports grouped together, but I thought I would break mine out because it was so long. But I had such a great time that there was a lot of stuff to squeeze in. But yeah,
Did you see the aurora? Did you see the aurora in Kalamazoo?
Yes, we had aurora on, what was it? First it was May 10th. That was the great solar storm. Then we had the Perseid meteor shower aurora. That was August 11th. I was actually imaging in our local observatory at the time, watching Perseids, and then walked out and saw the aurora in the northwest there. And then the next time was October 10th. I don't know why they were always around the 10th or 11th of the month, but that's just the way it worked out for us. And then Chungcheong Atlas was a pretty decent comet. It's definitely not a great comet, but I would call it a pretty good comet. But I thought Neowise in 2020 was better. And both of them paled in comparison to good old Hale-Bopp.
Yep, I was on a plane coming back from America, and it was right off the wingtip as we took off.
Well, that's close. I'm glad the plane didn't hit it.
Well, visually, and there was a American couple next to me, and I pointed it out, and she said, "Oh, gee, George," and it turns out he had the same name as me. And we had a chat all the way over. It was good. That's fantastic.
Sounds like there's going to be a decent comet visible from the southern hemisphere, another comet Atlas, but we're not going to be able to partake in that one, especially here in Michigan, because we don't get to see anything in January, at least not very often. We did get to see the lunar eclipse in 2019, but we had to cancel our viewing event because it was like 0 degrees Fahrenheit outside. And we have a strict policy for KAS events, as we prefer members or the public do not drop dead during the event. So if people came out in 0 degree temperature, I'm sure we would have had people keel over. So we had to cancel that. So I posted an image live online, and many of them went viral, which was really cool. That's never happened to me before or since. But
yeah, it can get cold. I was up on an Empire State Building in 2004, and I had to put my very twee digital camera underneath my arm to warm the battery up to take the next picture. It just wouldn't go.
Yeah. All right, looks like we're almost done there, so we'll go ahead and keep it on there. You can see we cooled our camera to minus 20 degrees Celsius. That's pretty standard. You can see some of the other features that we can use ACP for. if we want to do a series of images through different filters, we can do the color series, but I'm just using the single image panel here because we're just taking single images.
Hey,
You can't,
Richard,
yes.
can you talk about the tracking error there, or are there any numbers that you have?
You can hover over it. It's not very much. It's not a precise readout. It looks more squished than it is, but it's pretty sub arc second pointing. It's very small. Looks worse than it is. Or
Richard,
yeah,
how is the camera cooled down? I don't know much about those.
it's a thermal electric cooler. It uses like a heat sink to cool it. I'm not an engineer, so I can't describe it in detail, but it's a thermal electric thing.
Okay.
This camera does have the ability to have like cold water stream through it, but we don't bother with that. It's not necessary. And heck, with the newer CMOS cameras, you barely even need to cool them as much anymore because the noise is getting so good. Ah, there we go.
That explained those two pipes sticking out of the camera when you showed the picture. It was kind of surprising to me. So there you go.
Yeah. All right, there's our thumbnail. And again, we have to wait for it to do the plate solving. It'll count stars at the end there. And sometimes it takes a while, especially if there are a lot of stars. But you'll hear it go bonk, bonk. There we go. There's one. So 414 stars of 14,000 plus matched. All right. Are we ready? Image number 2. The California Nebula. There we go.
Oh, yeah.
Nice.
Ooh.
Like a
Very
horse. Doesn't it look like a coyote?
Like that. Star shapes are terrific all across the piece.
Yeah, so when I process this, it'll look a little bit brighter, but it is a pretty faint target. I mean, if I was doing imaging, imaging this target for a good picture at the end, I don't know, I might do 20-minute exposures, but I never do ones that long during an online viewing session. That's a long time to kill.
No satellite tracks. That's great.
But I just love those billowing clouds of this object. It really makes it cool.
A lot of texture in that image.
And we can scroll up and down here a little bit, but there's not much else to see than the narrow big object here.
Yeah, very good.
So this is one of the largest emission nebulae in the sky by apparent size. Again, it's 160 arc minutes by 40 arc minutes. 160 arc minutes is about 2.7 degrees. So roughly from maybe one end to the other, it's 2.7 degrees long. Probably at least the bright part. You can see there's fainter extensions that probably aren't included than the traditional measurement. So it's much bigger than many of the other emission nebula that we know. It's bigger, by a bit, at least in length, than the Hart Nebula. It's much bigger than the Orion Nebula, even bigger than the Rosette Nebula. So it's a very, very large target. So its true size is about 100 light years long and about 43 light years wide. It's drifting through the Orion arm of the Milky Way, which also contains the solar system, Earth, and you, of course. So it's in the same part of the galaxy as we are. And as hinted at earlier, it's probably illuminated by Xi Persei, or Menkeb, the star you can use to find it. I believe this is probably it right there. It doesn't look terribly spectacular in hydrogen alpha, but this is a pretty awesome star. This star shines at magnitude 4 from a distance of about 1,200 light years away. It has a surface temperature of 37,000 Kelvin. The surface temperature of the sun, for comparison, is 5,800 Kelvin. So this thing has a surface temperature of 37,000 Kelvin, and when it first formed, it probably had a mass of about 40 solar masses, but now it's between 26 and 36 solar masses, because this is a type O star. It's type 075 Roman numeral 3, which means it's a bright giant. So this is no longer a main sequence star. It's evolved off the main sequence, and O-type stars are, you know, the hottest and most massive of the stars, and they lose a lot of their mass in terms of stellar winds. So it shed off, you know, a few solar masses of weight just because it's so powerful. So this kind of relatively faint looking star, at least in hydrogen alpha, is, you know, one of the hottest and most massive stars in the sky. It's 13,500 times the luminosity of the sun in visual wavelengths, but stars like this give off most of their energy in the ultraviolet, and there it's 330,000 times the luminosity of the sun. So this nebula and the star as well are part of the Perseus OB2 association, which is, it's like a star cluster, but not bound by gravity. The stars are moving in the same direction, but they're not gravitationally bound like in an open cluster. So this is probably the nebula that many of the stars in the association formed from. And it's probably toward the end of its life. I'm sure at its peak, this was a much larger emission nebula in the sky. But there you have it, the California Nebula.
Well done.
All righty. So let's go off to our next target. Everyone knows this one, so you can, of course, observe this one with the naked eye, but sometimes it's fun to look at the familiar stuff with the equipment. And now we're going to do this little known cluster called M45. Well, it's not little known, it's very, very well known. So we're going to do a 5-minute exposure, this time with the luminance filter. So there we go. So M45 is, of course, the Pleiades, the seven sisters, located in the constellation Taurus. That's what the coordinates are for. The magnitude 1.6 is very reasonable because it's easy to see with the naked eye, even from fairly light polluted areas. It is big, 110 arc minutes, nearly 2 degrees across. So it is another job for the Takahashi. I mean, the 20-inch would show like this area here. So this is definitely a target for the Takahashi, and at 444 light years, it is one of the nearest open clusters to Earth. I believe only the Hyades is closer. So finding it is no problem. You can basically just find it on its own, just look for it in the sky. It looks like a little tiny dipper. In fact, I've seen many people tell me that it looks like the Little Dipper, or that they thought it was the Little Dipper, but nope, it is in fact the Pleiades, located on the back of Taurus the Bull here. So here's a more detailed chart if you really needed it, but you don't. It's easy to find. So of course the Pleiades is referred to as the seven sisters, after the 7 doves that carried ambrosia to the infant Zeus, or to the 7 sisters who were placed in the heavens so they might forget their grief over the fate of their father Atlas, condemned to support the sky on his shoulders. And it's very well known as the 7 sisters. Most people can see usually only 6, but 10 stars brighter than 6 magnitude are visible. And Stephen James O'Meara, very well-known visual observer, once saw 7 Pleiades, 7 members of the Pleiades from Cambridge, Massachusetts. So if you have very good eyesight and a lot of patience and, breathe, you might see that a lot more than your typical 6 or 7 members. You can see as many as 17, which is pretty remarkable if you can do that. So it's been known since ancient times in cultures across the world, including Chinese, Japanese, Persians, Mayans, Cherokee, Aztecs, the Sioux, and Aborigines, because obviously it's so easy to see. The Japanese mentioned it as Mitsurabushi, which means 6 stars, in documents dating back to the 8th century. They also call it Subaru, meaning coming together or cluster. So on a Subaru car, you see that little cluster emblem, and that's supposed to be the Pleiades. The Pleiades is mentioned in the Iliad, Homer's Odyssey, the Bible, and the Quran, among other texts. So it is very well known to modern day observers and throughout history. All right, let's see how we're doing. Oh, we're already off in imaging. So now the Pleiades is another target where I never had trouble getting a guide star, but or doing plate solving. So I'm glad to see that it did it again. So it's working very, very well. Phew, that's a load off my shoulders because that's been a pain not having the Takahashi point right. But we had to take it off earlier this year because we sent it in to get it collimated, which was partly successful. And then the pointing hasn't quite been right since then. Although it seemed fine to me at the end of June, but didn't really have time to look at it in detail, I suppose, because we shut down the remote telescope during the summer months of July, June, and August and September, because it's monsoon season out there and we don't have insurance, and many observatories out there have been fried by lightning, and of course they're fine because they're insured, but our equipment and somebody else's building is not insured. So we err on the side of caution and we just unplug the thing during the summer. Most of us would rather be outside under the real sky anyway, but so better to be safe than sorry. And I'll give you a spoiler. The Pleiades will appear upside down in the image, but when I give them to you to download later, I will flip it over into its more recognizable pose. So that might confuse people at first when you see the image, like, well, why is it upside down? And that has to do with the mount, which we can peek. I'm not going to turn the infrared on since we're imaging, but we'll take a peek at that later. And so we're looking right there right now. That's pretty easy to find. There it is. Maybe we'll get some amp glow or some annoying glow from Jupiter. No, we won't. It'll be fine. And now we can see safe. So we got all of Orion now. And there we go. So we got Rigel, Aldebaran, and Capella in the winter hexagon. Yep, and this is Gemini here. You can just see Pollux there, and there's this little stick figure. He has like little legs and a body and a little short arm there and a little long arm there. So that's Pollux, and these have got to be the feet of his brother Castor, rising higher and higher. And it looks like we're getting some sky glow. Looks a little on the greenish side. Just shows you how dark it is out there. Sky glow is the more natural nighttime light pollution, but there's nothing you can do about it. It's a chemical reaction caused by sunlight during the day.
So are those clouds, or it looks like?
I don't believe so. No, it's probably gravity waves, perhaps in the sky glow. But it looks pretty clear.
Yeah,
we can check
the satellite. Satellite looks clear.
Yeah. Let me see if I can get rid of the zoom controls. I'm going to stop moving the mouse for a minute. Go away, zoom controls. Jeez. I was going to try to bring on another. Let me. Oh, go away. Let me. Here. Here we go. We'll click that. So this is our neighbor's all sky camera, Dave Churchill. He uses the exact same setup that we have for the all-sky camera. In fact, we got the idea from him. And yeah, I think those are like gravity waves in the sky glow. It looks very clear there as well. You can see his is processed better than ours. The guy, that terrible person. All right, I can't get to the zoom controls again. Dang it. There we go. There we go. Okay, we're all done. We have the thumbnail, but I haven't heard the bonk bonk yet. 31,904 stars found. And again, it'll pick about 400 of those for plate solving. So it's going 1, 2, 372 stars matched. All right, are we ready? Here we go. Here comes the Pleiades. You can see it's upside down.
Oh, wow.
Nice.
That's cool. That's magnificent. Way to go.
It looks like the football stadium lights.
They got a lot of nebulosity there for just 5 minutes.
Yep.
It's
Oh, yeah.
2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7.
So the Pleiades is 100 million years old and composed of hot, blue, highly luminous stars belonging to spectral type B by and large. It contains about 100 stars in a sphere of about 15 light years in diameter, has a tidal radius of 43 light years. It has a total population over 1,000 stars, not including unresolved spectroscopic binaries in very dense or close systems. It's estimated the cluster will survive for about another 250 million years. Some of the really big stars might die, but by and large, it'll lose stars through gravitational interactions with other stars and gas clouds in the galaxy. The reflection nebula, which is what we see here, around the brightest stars once was thought to be leftover material from the cluster's formation. But now we know the Pleiades is just plowing through the Taurus Auriga complex of dark nebulae. In fact, in really deep images of this region, you can just see the cluster plow through dark, obscuring clouds of soot and material. It's really amazing. So it also contains many brown dwarfs, or failed stars. And that makes up about 25% of the cluster's total population, and less than 2% of its mass. And who knows how many planets are around some of those young stars in the Pleiades. But at 250 million years old, I doubt there's any intelligent societies around any of those stars. It's too young. And just for shameless purposes, I call this line of stars here the bell string. That has nothing to do with the fact that my last name is Bell. It's just a coincidence. But if you show this to people in the future, this image, or talk about the Pleiades, please tell them this is called the bell string. I'm trying to get that to catch on. I've been trying for 30 years and still haven't had any luck with that. So help me out, okay?
Now that you say that, I see it clearly.
I mean, it sounds very astronomical, the bell string, like string theory.
Cool.
All right, so that is our last target for the Takahashi tonight. So let me scroll back up here. I'm going the wrong. No, I'm going the right way. Go down here, and now we're going to switch to the big scope. Oh, but before I do, because I always forget, let me switch over to the home computer here and change the aperture and the focal length. Because I've forgotten to do that many times, and it's come back to haunt me. Okay, I think I got it. All right, now I'm gonna hit the switch to 20-inch, and it'll start working on that in the background. Here, let's turn on the camera real quick before we go off to the PowerPoint again, but oh, we missed it. I was hoping to get the flip flat just closed, so the Takahashi's officially covered up, and nothing will change here for a while now, so we'll go ahead and leave that behind. But we're going to switch to the big scope there now. So let's talk about that for a quick second, because it takes a second to switch over.
Richard, does the flap automatically go across the Takahashi as soon as you switch it? You don't have to do it separately on the Takahashi, but directly you change the scope, it does it. It's in a code sequence to do it.
Yeah, we just have a little script to switch between the two telescopes.
And the first thing it wants to do is shut the lid.
Yep, that's all automatic.
Yeah, cool.
We'd like to get automatic cover for the 20-inch, but it costs $5,800. That's a little expensive, but it stays pretty clean, cleaner than you might think in that dusty observatory. So here it is. This is our plane wave CDK 20, which means it's a 20-inch corrected dull Kirkham telescope. A dull Kirkham is a telescope with an ellipsoidal primary mirror and a kind of a spherical secondary mirror. And there's a lens group in the back that helps correct the image, hence the C in CDK. So it does have a 20-inch mirror, and you can see it's a pretty long focal length, but, you know, not for your typical 20-inch. You know, this is the focal length of like a 12-inch Schmidt-Cassegrain. And it is pretty heavy. It does weigh about 140 pounds. When we first put it on the mount, there's a picture I could find, but there's like a four of us holding on to it for dear life. And then on the back there, we have our other S-Big STX 16803 CCD camera, which we also will replace here in the future. So if you're in the market for a really good CCD camera, we have two of them for sale. And we currently use an on-axis guider, but we're going to be getting rid of this soon. We haven't really been terribly happy with some of the results, and installing this has forced us to move the secondary, which creates some vignetting in the image you might notice later. And once we remove the on-axis guider, we're going to use a traditional guide scope, and that means we can relocate the secondary mirror to its original position, and that should give better images. But the vignetting isn't a huge deal because we can flat field that out. And then this little camera here is the auto guider that we used earlier for the Takahashi, because earlier we were imaging with the Takahashi, but we are actually guiding with the 20-inch. So that is a big guide scope. But pretty soon we'll have a smaller 50mm guide scope to do all of our guiding for both telescopes. We'll try that out and see how that works. So both telescopes, the 20-inch and the Takahashi, are supported by a software BISC Paramount ME2. Pretty good mount, but to be honest, there are times I wish we got an astrophysics instead, because the 1600 astrophysics that we have in the observatory has been kind of no problem at all. But this one we've had some issues with here and there, so sometimes I wish I got the astrophysics. So if you're in the market for either a big Paramount like this or an astrophysics, I would tell you to get the astrophysics now as opposed to this one. But overall, it's a really, really, really good mount. Just the astrophysics is a bit better in certain areas. And it does have a 240-pound capacity, while the 1600 astrophysics has a 220-pound capacity. So they're nearly identical. But it is a good mount. I don't want to bad mouth it too much. All right, let's see how we're doing there. We should be all switched out now. What did I do with my? Oh, here it is. I couldn't tell which one was the. We'll turn it on here again real quick. But there we go. Yep, hasn't moved a bit, but it shouldn't. I thought we'd just check in on it there. So we have successfully switched. That's good. All right. So while we're there, we're going to put in our next target. And I figured tonight, every target that we're going to do with the 20-inch tonight is new. We've never done any of these before during the online viewing session. And some of them are a little on the obscure side. They're not really well-known objects. So I thought we'd have a little fun with that tonight. Like type it in there. So NGC 246, you can cheat and find out what that is. What are we doing on time? I think we're doing good. Let's go ahead and do a 10-minute shot of this one. I was going to do 5 minutes, but it is kind of faint, and I was hoping to bring it out a bit more. So let's live dangerously and do 10. All right. So let me tell you a little bit about this one. So NGC 246 is known as the Skull Nebula. It is also designated as Caldwell 56 from the Sir Patrick Caldwell Moore list of objects that Messier missed. So it's also Caldwell 56. And in terms of the name, it's also known as the Pac-Man Nebula. But in this case, it's Pac-Man Nebula. But there's also NGC 281, which is the Pac-Man Nebula, but with no hyphen. I don't know why that makes a difference, but it does. But Skull Nebula is taken for another object as well, but it's much more known as the Rosette Nebula, because apparently there are some people that have called the Rosette Nebula the Skull Nebula, but you know, in most literature you'll never find that, but that's kind of an obscure reference. But so we'll call this object the Skull Nebula, which is a planetary nebula. It's one of about a dozen planetary nebulae in the Caldwell catalog. As we talked about last month with the dumbbell, in the Messier catalog, there's only 4. But in the Caldwell catalog, there's at least a dozen. So it was discovered by William Herschel on November 27th, 1785, with his 18.7-inch reflector with a focal length of 20 feet. And so when Herschel first observed this, he described it as 4 or 5 pretty bright stars forming a trapezium of about 5 arc minutes in diameter. The enclosed space is filled up with faintly terminated Milky Way nebulosity. The stars seem to have no connection with the nebulosity, and he was right about that. But the thing that mystified people about that comment is, where is the trapezium? Because you can see kind of a triangle here, but some people think he was including, I think, this star as well. But we'll see the triangle here soon, and this is the central star in the planetary. But that trapezium part has always mystified people. So it is in kind of an obscure part of the sky. I mean, at least for us here in Kalamazoo, because we often go to the Nature Center for at least public sessions. And from there, Cetus is washed out from downtown Kalamazoo. So you have to have a pretty dark sight to see Cetus well. But it's kind of located up toward the head of the whale here. So that's its rough location in Cetus. And this shows the whole constellation. This is actually 2 charts that I scanned and melded together, but because I wanted to really show where Cetus is again, because you know, if I just show a close-up, it really kind of loses something. But here's its position in the sky. So it's located, you can start from Beta Cetus, which is Dipta, it's Beta Cetus, let's just put it that way. And so you move 7.5 degrees to Phi Cetus, this little line of stars here. And there's Phi 1 and Phi 2 here and here. And then you go 1.5 degree farther east for 2 there. And then you just kind of go roughly down a bit to look for NGC 246. So, of course, today most people would type in NGC 246 in their go-to computer, but if you're an old school big knob star hopping type guy, that's how you star hop to this thing. You just kind of start from Beta Cetus, look for the line of stars here, kind of go from this one, and just kind of hop down about a degree or so, and you'll find it. Or you can do 5.5 degrees west-southwest of Eta Cetus over here. But it's easier to use this line of stars to find it. So that's where it is in the sky. All right, let's see how we're doing there. Uh-oh. Did I forget to hit acquire image? I thought I did. Nope, I didn't. Oh, I missed it. Well, okay. Well, I thought I hit it. Well, it's running now. Oh, darn, I forgot that, or I didn't hit it good enough. Well, I hit it now, so there we go. I was hoping it would work in the background while I gave you all the information there, but that was my first big error of the night. Oh, darn. And now for some reason, the focuser is going to home. Well, that's going to be annoying. We're going to have to figure out why that's happening while the focuser is homing. We must have some screwy setting and focus max, so that's going to be a bit of a delay. So
what's the focuser on the CDK? Is it the secondary, or is there a?
No, the focuser on the CDK is a Finger Lakes instrument focuser. In fact, let me here. We'll kind of hop back and look at that. Oop, I don't think I shared my screen properly. So you can't really see it in the image too well. But let me see if I can just do a quick shortcut here. Whoops.
Good night.
Can you see that? So it's this little box on the back.
Oh yeah, I can see that.
So that's our focuser right there, this little funky looking box on the back. And if we could have sound in the observatory right now, this thing is really loud. When we first used this thing to focus, we were shocked how loud it was. But it's very precise.
How much range does it have?
I don't recall off the top of my head.
Oh.
But if we're going to switch to your more standard full frame camera, if we raise enough money, I might switch off to the plane wave focuser that's also a rotator. Because with the big square chip that we have now, who cares if you have a rotator? It's square, it's not going to make any difference. But if we get the more 36 by 24 camera, there are times you might want to rotate that a bit for some targets. So we might eventually switch this out with one with a rotator. So if you are a member, we're eventually going to start the fundraising campaign there. But it won't be as big as the initial fundraiser, because for 7 years, from roughly 2011 to 2018 or so, we raised about $120,000+ for this thing. So it's the biggest fundraiser we've ever done. About 60% of that was for members. So now the club is over twice the size that it was back then. So we shouldn't have any trouble raising the money, but there's probably tough economic times ahead. So if we're gonna do it, we better do it soon. All right, let's see how we're doing. Let me I'll show you the computer. So this is the computer in the observatory that is connected directly to the telescope, and it's slewing right now to the target because we're looking at a different part of the sky, probably even on the opposite side of the meridian, so it has to slew all the way over. So it is still in the process of slewing. You can see ACP is in use because the little siren thing is flashing there. Then eventually what will happen, you'll see Maxim change this to a 20-second exposure, because it'll do a 20-second plate solving image. And usually it matches it the first time, but if it doesn't match it the first time, then it moves the telescope a little bit. It does like an offset image, and that's another 20 seconds, but usually the first one does it. And then it'll center the target, and then it'll look for a guide star, and then it'll guide, then it'll image the target. So it sounds like a lot, but it's all automatic. All we have to do is sit here and watch. And now it's doing the 20-second plate solve. You'll see that pop up really fast. It doesn't stay up long. There it is. See, it goes pretty quick, but it's already counted the stars and it's already solved it. So that was really fast. So it solved it for 53 stars this time, unlike the hundreds with the Takahashi, but that's a much wider field of view. The plane wave field of view is it's about equivalent to the full moon. And oh my, and now there are no guide stars whatsoever. Oh my goodness. And this is part of the reason why we're going to switch to another guide camera. So now it's just going to do the image unguided. And it looks like there might be stars there, but we may have lost our focus because the focuser rehomed itself. So I hate to do this, but
What's that glow in the lower right?
I don't know what that's from. That's part of the thing, I think, with the on-axis guider, and part of the reason I just want to do away with that thing. So I'm going to go ahead. I hate to do this again, but I'm going to go ahead and kill this because I think it might be out of focus. It looks like it's out of focus to me because something's wrong with the focus max setting. Whoop! Ow! No, no, not that one. Not that one. Ow! All right, I think we're still okay. But I hit the script to shut down the observatory. I want to hit this one. Uh-oh. All right. Oh, Richard's really messed up tonight. Let me try it again. Okay, I think it's okay now. I was afraid I was going to have to run the startup sequence again, but I think I caught it in time. Oh, there we go. Okay, so I'm going to type in. Of course, you probably can't see this, but I just have the sneaking suspicion we lost the focus that I had earlier. So we need to check the focus max settings so it doesn't home every time. For some reason, it's doing that, and it's not supposed to do that. So something got changed inadvertently. All right, so we'll keep it on the screen here, and you can see it focus. So that's doing a 20-second plate solving for the focus because it has to look for a focus star of the proper magnitude. That looked pretty focused though. So maybe we're just having bad luck getting a guide star, but I could have swore I saw 2 stars there that looked out of focus. But it's better to be safe than sorry, I suppose. All right, so now it's doing a half-second exposure to look for the star. And it'll pick the star. There it is. So that looks pretty good. At least it didn't have to home the focuser again. Well, maybe we'll scale back our image to 5 minutes to save a little time. So you'll see the curve here get sharper and sharper. It gets pretty sharp, but not as sharp as with the Takahashi. But very different image scale. Oh, that looks a little funky.
Which filter did you select, Richard?
I always do the luminance filter. One thing I've been working on is trying to get it to focus with the narrowband filters because it doesn't work with those at all. It does focus with all the colored filters, but not the narrowband filters. I've been having issues with that.
Yeah, much dimmer image.
Yeah. All right, looks like we're done. Nope, not done. It's moving it to another position. Getting there. Looks like the weather hasn't changed very much out there. 21% humidity. Man, that makes me mad. We practically drown here in Michigan. It's so dewy. All right, now I think now it's done. Okay. So let me go to the screen here so you can see what I'm doing. Okay. So I think I'll change it. We'll just stick to 5, save some time here. All right, and I did hit it this time. Let's switch back to the home computer, see if we actually get a guide star. Wait, we can get rid of that star now. We don't need the focus star. We can get rid of focus max. Let's make that go away. And now for some reason it's homing the focuser again. What is going on? It's not supposed to do that. I don't have it checked off for autofocusing, so that is weird. Well, we're going to be in the same boat. I'm not going to do it again. Hopefully it'll return it to its original position before it homed itself again. So we need to check the settings and tell it not to home every single time, because that's not supposed to do that. All right. As soon as we wrap up the session here tonight, we will investigate that. It's just a bad setting. I have been working with it with the narrowband filters, but I haven't changed anything else. So something changed on its own. You can see it change. So it should go back to its original position. It was like 59,000 something or other when it's done. So we should be going here in a few minutes. So if anyone needs to take a break, it'll be a few minutes here. So, well, let's check on the all sky camera. There we go. Looking pretty good. Still got those funky waves in the sky glow. But that is not clouds. That's got to be sky glow with maybe gravity waves in it or something. Or it's just the structure of the sky glow. But now you can see Pollux. Pollux has popped up. So we have all of Gemini up now. So we have another star in the winter hexagon there. I only include Pollux in the hexagon. Some people include Castor and Pollux, but I just include Pollux. So now we're just missing Procyon and Sirius. We might just see them at the end of the night here, but I don't know. we go. Oh, that's how you switch tabs. Should be getting a guide star here. Well, maybe not, but okay. Now it's doing a 20-second plate solving to center the target, and then it'll look for a guide star, which I think we're going to strike out. Oh, the position is not the same as it was. That's not good. I should have wrote down the position and then I could have just moved it on my own.
Position that it had was 59661.
Okay. There is a star up here. That does look like a star right on the edge of the field of view. So maybe these aren't, maybe that's not a star after all. Well, we'll just let it run. That's the best we can do. I don't want to go through all that again. All right, so we'll just let it go. So fun night on the online viewing session here. Seems like we keep having technical issues with either the Takahashi last month and now with the Focus Max with the plane wave this month. That's really strange. But the notice the other focuser on the Takahashi didn't home itself every time. So I don't know why this one is. That's strange. It's clearly a setting with the plane wave, not with the Takahashi.
Would you compare the two scripts to see where they're
yeah, I'll just have to look at the settings, but it's obviously something with the plane wave. But yeah, if I can't figure it out, I'll compare it with the other scope. But it should be something simple. So I appreciate everyone bearing with us there. Let's go back to the all sky. Just look at something. Curious structure in the sky glow there. But yeah, those are not clouds. We can scroll down, check out the windy thingy here. Look at the satellite. Yep, looks very clear. There's some clouds way up there, but it's very clear in Arizona and New Mexico. And ASV is like right around here somewhere, I think, or maybe a little north. No, it's like right up here because there's like a road here. I don't remember what road that is, but I think it lines up right here with Arizona Sky Village. And this sensor graph is from the weather station that I showed you on the main computer earlier. Then we have the clear sky chart. It's supposed to be a pretty good night for seeing. Last month, if you joined us, the scene was about as worst as I ever have seen out there. I mean, it was really bad last month. Holy cow. But this month, it looks a lot better. And of course, if you ever want to find this page, just go to our website, kasonline.org, go to the remote telescope menu. Oop, no, I just reloaded. And just pick the Piishi all sky camera. And that takes you to this page here. So you can check it all the time. We do let it run during the day, but we're still having kind of a overexposure issue with the sun, which is mainly from internal reflections of the camera. So we need to put a mask.
The sensor?
What's that?
Is there any risk of frying the sensor?
No.
Because you're not directly on the sun's path.
No, it's so wide field of view, it doesn't make any difference. Our neighbor's been running his identical camera for for longer than ours, and his is still kicking just fine. And our previous camera never ran into any issues with the sun either, and that had worse blooming issues than this camera does. All right, looks like we're almost done there. We'll see how it looks. Hopefully it's reasonably in focus. If it's not, I'll include a previous test image that I did earlier this week just to see how it looked. Because before this week, we never imaged this target before, ever. Because it is not a really well-known planetary nebula. It's definitely not a showpiece object, but sometimes we like to do those obscure targets that people don't know about. And this is one of them. I know the suspense is killing me.
Just for clarity, Richard, it's not two of me on there. I've got a mobile phone with buds in, and I've got the sound down on the laptop so that I don't disturb my wife.
Okay.
It's just sits in there, noise cancelling, and she doesn't hear a thing.
There it is. You can tell we're in a pretty sparse part of the sky. Not too many stars detected. All right, are we ready? Finally, here we go.
Yeah.
Let's see how it looks. That's not too bad. That looks reasonably focused.
That's nice.
Yeah. So there's that triangle that we saw on the sketch earlier. But where the trapezium is, I have no idea. All right, so this is the first known planetary nebula to have a hierarchical triple star system at the center, which means you have two stars very close to one another that orbit each other in close proximity. So they basically act as one star. And then you have another star that orbits around the two. They all share kind of a, they all orbit a common center of mass, but it's like two stars in orbit around each other, but one of them is a really close binary pair. So the main star in this triplet system is a 12th magnitude O-type dwarf star, cataloged as HIP 3678A, or we'll just call it A for now. And it has an effective temperature of about 150,000 Kelvin, but a mass of only 0.84 solar masses. So it's a star rapidly becoming a white dwarf. And so the progenitor star, before it lost a lot of its mass to form this planetary nebula, had a mass of about 4.3 solar masses and a main sequence lifetime about 260 million years. So it was probably like a type A or F star, most likely. The second companion, which is close to the A star, is HIP 3678b, and that's thought to be a mid K type star, kind of an orange star, smaller and cooler and lower mass than the sun. And in fact, the mass is only 85% that of the sun. And it does have a separation of 3.8 arc seconds, which works out to about 1900 AU from the primary. The third star that orbits the two is HIP 3678c, which is a red dwarf of spectral type M5 or M6, and that only has a mass of 1/10 or 10% that of the sun, but a separation of about 1 second, 500 AU from the primary. The nebula has a age of about 6,600 years, and it's currently expanding at 24.5 miles per hour, or 39.5 kilometers per second for those of you that wisely use the metric system. Its physical diameter is about 1.8 light years, and that's assuming the distance of 1,600 light years is correct. So there we go. It took a bit to get there, but this is the first time we've ever checked out NGC 246, the Skull Nebula. Not one of the sexiest targets in the sky, but again, a pretty decent planetary that's not widely observed. So there we have it. Stellar roadkill tonight. All right, now let's go to a really cool galaxy that's also kind of obscure. NGC 1232, I believe is the correct designation. And we're going to go ahead and stick with 5 minutes there and make sure I hit it properly this time. And before we go off to the screen to learn more about it, let's, I'm curious to see what's going to happen with this thing. Let's close all that stuff there. Let's see if it's going to home the focuser again. Which is really infuriating. Because 52,500, that's its default position. So of course it might slew first. We haven't done that tonight. Let's see if we can get the thing slewing. We'll turn on the infrared camera there for a second. So there's the position of the telescope when it did the planetary nebula. Yep, it is homing the focuser again. That is super annoying. Why is it doing that? So while it's doing that, let's go ahead and check out this object in a little more detail. Oh, let me turn off the infrared camera. All right, so NGC 1232 is called the Eye of God Galaxy. And here are right ascension declination that works out to be in the constellation Eridanus. But that alone doesn't necessarily narrow it down because it is a big constellation. It is a magnitude 10.9 galaxy. So pretty faint, but not too bad for the 20-inch. But it is big. 7.4 by 6.5 arc minutes is nothing to sneeze at compared to your typical galaxy, which is very small. And this thing is about 61 million light years away, plus or minus 8.5 million light years. I don't always put the air in there, but that seems a little larger than usual to me. So I included that. And this object is so obscure, I suppose, I could not find any sketches online, which is a first for me. Every sketch I usually show here has been found online, but this one I had to scan out of a book from Stephen James O'Meara. So it's a really cool galaxy, but not widely observed, maybe because of its low altitude for most observers in the Northern Hemisphere. So Southern Hemisphere people, maybe it's a little more popular down there. So Eridanus is the river. It starts from the edge of Orion here near Rigel and kind of winds across the whole sky here. So it's a very big constellation. And we find the Eye of God galaxy right about there. Or more specifically, you can again look for instead of phi, you can look for a tau line of stars here. You got tau 9, tau 8, and so on. And so you can start from tau 4, the westernmost of the 3 4-magnitude stars that form an arc about 6.5 arc minutes wide, oriented kind of north, northwest, and south, southeast. the other two being Tau 5 and Tau 6. And then with this star centered in your finder scope or your eyepiece, just move 2.5 degrees to the northwest, and that'll take you to NGC 1232, which is immediately southwest of a 1 degree wide sideways Y that you can't see on the star chart here, but it's probably there. So let me back up here because I jumped ahead a bit. So other designations for this galaxy include PGC 11819 or ARP 41. PGC is the principal galaxies catalog, a list of 73,197 galaxies published in 1989, while the ARP catalog is the Atlas of Peculiar Galaxies, which only contains 338 peculiar galaxies, usually those involved in collisions and stuff like that, or at least look a bit odd from your normal galaxy, although by and large, this is a pretty normal looking galaxy. So in a 16 to 18 inch telescope, according to the Night Sky Observer's Guide, it is a bright, large 7 arc-second diameter galaxy displaying an oval core and a faint stellar nucleus. The halo contains many knots and condensations and a very faint clockwise spiral pattern. And we should see a lot of that in the image, a lot of that structure that's described there. This was discovered by William Herschel on October 20th, 1784. He described it as a faint nebula, very large, a little bright, a little brighter middle, 7 or 8 arc minutes in diameter. So it's a pretty good sized galaxy, but again, very obscure. And it sounds like we had trouble looking for a guide star again.
That might have been me. Unfortunately, I still had Outlook up, and I think a mail came in and pinged me, and it's come across.
Yep.
I hope it was me anyway.
Oh, here we go. Sometimes I can't find the screen. So yeah, I didn't have any trouble with guide stars earlier, but it might be because the focuser it keeps homing, so it can't be in sharp focus, and if the focus is a bit off, it often has trouble looking for guide stars. So I think that's our issue. So we got to fix focus, Max. That's all there is to it.
It seems strange, Richard, because you're using the same setup to guide on the Takahashi.
It's just some strange setting that tells it to home every time. It's probably a quick fix, but I won't bother to take time to do it tonight. I should probably just focus again for the next target. I'll just have it focus automatically because it's going to home anyway, so you might as well focus while we're at it. But that does take a little extra time. Can see if we have the... Oh, go away. Yeah, the stars, looks like there's stars there, but I mean, we are in obscure parts of the sky, but in testing, I didn't have any problem getting guide stars earlier in the week. So, you know, the rehearsal goes fine, but then when you actually do the session, things just go haywire on you. That's the way it always goes. So there's not much there. But we can get away with usually 5 minutes. I mean, the other image was 5 minutes and wasn't terribly trailed at all. So the Paramount's good enough to where you don't need to seriously guiding. But if I was trying to take a pretty picture, I would be very upset. Well, we're halfway down there. Let's go back to ACP. Check on the all sky camera again. Boy, a lot of structure on the sky glow. That is remarkable. But that just shows how dark and transparent it is out there tonight. I think there's a faint trail right there. Maybe probably a satellite, most likely. No new stars in the winter hexagon have popped up yet. And we'll just let it run. So again, anyone has any questions or comments?
Yeah, NGC 1300 is a member of this cluster that 1232 is a part of.
Yes, I was gonna image that one first, but then I decided to do this one because NGC 1300 is one of my favorite galaxies because it's like the textbook barred spiral.
Yeah. Yeah, I tried imaging it from up here in Michigan, and I only have like maybe an hour, 2 hours at best.
Okay.
You know, it's so low. So remote telescope would have a lot better time.
I even had notes ready for NGC 1300, but so we'll save that one for next year.
Yeah, that's a great galaxy.
But I figured being so close to Christmas, you got to do the Eye of God galaxy, right?
Yep.
But I'm surprised, Richard, that you'd say it's a difficult target, because I'm looking at it in Telescopius and Stellarium right now, and it looks like you could get 3 hours on it if you started at 11 o'clock, or maybe 10 o'clock.
Yeah, I think the problem is it's low, it's large, so it has low surface brightness like M101, but it doesn't get nearly as high in the sky as M101 does for us in the northern hemisphere.
Right. No, it's at 40 degrees and shooting down, right? So
yeah, you can see the current altitude, the ACP here is 35 degrees.
Right.
So it's not terribly high. If I would have done that target in Cygnus, this would have been its altitude at the time we would have inched it, but probably would have been okay. But all right, we're done. There it is. And this is one that'll look better later when you can download it and you can zoom in and see the structure. All right. Now, it shouldn't have to count too many stars. Now it's only 1,974, down to 88 catalog stars. All right, here we go. The Eye of God galaxy, little trailed. I will replace this image with the one I did earlier this week that looks a lot better than this one because we lose some of the structure in the trailing. So it's a little disappointing, but it's all Focus Max's fault. So this thing is big. It does have a linear diameter of 200,000 light years. Compared to the Milky Way is about 100,000. So it's at least twice the diameter of our galaxy. According to some sources, it has a total mass of 120 billion suns, which seems reasonable, and a total luminosity of 40 billion suns. It is a type SAB RS in parentheses C galaxy. So SAB means an intermediate spiral galaxy containing a weakly barred spiral. So you can see the nucleus is a little on the barred side there, even though it's probably trailed too, but it is slightly barred in the center, very much like the Milky Way. The RS in the designation indicates a so-called transition galaxy, which means it's probably going from a regular spiral to a barred spiral. And the C refers to the state of the spiral arms, which means they're very loosely wound. So they're not tightly wound around the nucleus. So it can also be technically considered a grand design galaxy, at least according to the sources, and is considered a prototype for multi-armed spiral galaxies. But I've always considered grand design galaxies with two perfect spiral arms with no branches and spurs and that sort of thing. But this thing has a multitude of branches and spurs and all that sort of thing, very much like the Milky Way. So it's not a grand design, at least according to the way I used to teach it in my astronomy class. So observations with the 4.1 meter Southern Astrophysical Research Telescope or the SOAR telescope at Cerro Pachán, Chile, revealed 976 H2 regions or emission nebulae, regions of star formation in 2018. 4 degrees to the east-southeast is NGC 1232A, which is right there. And in the image that you will get to download, you'll be able to see this galaxy a lot more clearly. But here it looks a little distorted. So this is initially thought to be a satellite galaxy to NGC 1232, but it is 6 megaparsecs or 19.6 million light years more distant. So way too far away to be a satellite galaxy. And this is though a starburst galaxy. It's a galaxy undergoing a lot of star formation, most likely caused by a collision with a galaxy that we can't see. So both galaxies are probably members of the Eridanus cluster, which does include NGC 1300, as Pete mentioned earlier, and that's a cluster of about 200 galaxies. So a little bigger than the local group of galaxies, but not a rich cluster by any means. So there we go. Not quite the view I was hoping for our first target there, but again, I'm going to ditch this one, and I'll give you the test image that I did earlier in the week, because again, the rehearsal image always seems to go better than the actual image. So
what was the duration of the test image the other day?
I'm sorry?
How long was the exposure?
The same. It was the same.
Thank you.
Yep. All right.
That reminds me a lot of M74.
Yeah. All right. Now this time I'm just going to have it focus because it's going to home it anyway. We might as well tell it to focus it too, so it's focused. But I figured we would end the session with the big, bright, beautiful star cluster. And so we will do M34, which is, again, the first time we've ever done this cluster during a session. So lots of big old, bright, Christmassy looking stars for those of you that celebrate Christmas. All right, we're off and running there. All right, so M34, as I learned this week, is known as the spiral cluster, at least to some people. As far as I knew, it was always just M34, but I'm trying to figure out why it's called the spiral cluster, because I don't see a spiral pattern. But I guess with all these stars, you can make up just about anything you want. So it was probably discovered by the Italian astronomer Giovanni Battista Hodierna before 1654, and it was independently discovered by Charles Messier on the night of August 25th, 1764, the same night he observed M33 for the first time. He described it as a cluster of small stars a little below the parallel of Gamma Andromeda. In an ordinary telescope of 3 feet, which is the focal length, one can distinguish the stars. So he knew it was a cluster of stars, but he still included it in a catalog of comet masqueraders. But I guess maybe even through a smaller telescope, it would look more cloudy and comet-like. So unlike some of the other targets that we looked at tonight, this one is easily visible to the unaided eye under good conditions. And it is actually best viewed in either 7x50 or 10x50 binoculars or a wide field telescope, maybe a refractor or a short Newtonian. And you can see about 20 stars visually. We should see more in the target here tonight. So if you looked it up, I mentioned we would be looking at something a little off to the short side of the wishbone here. The California Nebula is over here. But now we're going to go to the other side of Perseus and look over here. So it's pretty easy to find. It's located northeast of the midpoint between the famous eclipsing binary star Algol, the demon star, or Beta Persei. There it is. And the beautiful binary star Almach, or Gamma Andromedae. So go midway between those two, little north, and you find it. And there's actually a faint magnitude 14.4 planetary nebula called Abell 4 that lies 40 arc minutes east of M34. Large telescopes reveal a round disk with an O3 filter, but I don't believe it'll be in the field of view of the 20-inch. At least it wasn't in the test image. But there are a couple surprises in the test image that I never noticed before, and I'll hopefully point those out here shortly. So another famous object in the region, at least for me, is NGC 891, a really nice edge-on spiral galaxy. We've done that before during the session, because I love those edge-on galaxies. All right, let's see how we're doing. We're probably still in the process of homing the focuser. I thought I could tell. Something's happening. Or it's slewing. It doesn't say it's slewing. Oh, no, it is. It's slewing now. Let's see if we can catch it slewing and progress here. Because we haven't done that tonight. If I can find the browser. Which one's the browser? There it is. I got too many windows open. Oh, it's already slewed. Oh, darn. Because this thing is pretty high. All right. Sounds like we're focusing now. Let's switch back and look at that. Let me turn off the infrared camera in case I forget. And we can see it focus again. Now, notice as far as I can tell, it didn't seem to home itself when I told it to focus itself anyway. That's strange. Huh. But I figured it's going to home itself if I don't focus, so I might as well just focus. And hopefully once we focus, it won't home itself. It should. Now, if it does that, I might have to drive out there and take a baseball bat to it. It's not supposed to do that. As I recall, it did this to us last month, but it didn't seem to be nearly as annoying. But this time it just kept popping up over and over again. Well, let me wrap up the PowerPoint here while we're waiting, while we have time to kill here. So if you are a resident of the Southwest Michigan area, and you are either a current Kalamazoo Astronomical Society member and have not paid the fee, or you live in one of these counties, you can join the club, pay the remote telescope fee, and you can actually use the remote telescope all on your own. We don't open it up to people outside this area because it's not a commercial telescope. And as volunteers, we just would not be able to handle the demand. And to be frank, it works for the most part really well, but it doesn't work well enough for a commercial product yet. But by and large, we rarely ever have serious issues with it. But it doesn't work good enough for our satisfaction to try to make a ton of money on this thing, and we just aren't concerned with that. So our next online viewing session is on January 18th, weather permitting. If the wind or clouds get in the way, we have a cloud date of November 25th at 9 p.m. And while we're doing that, let me collapse all this stuff here and get to my, here we go. Oh, I could have done it that way. We put all these links on the chat here that I'm going to mention. We'll just do it all at once. There we go. So in the chat, I posted a registration link. So if you want to register for the January 18th session now, you can just do that now or get it out of the way. But if you are a KAS member, or are already on the online viewing session email list, you will get a registration link besides that, so you can just ignore the link that I posted because you'll get one by your email. But if you are not on the online viewing session email list, you can do so right now. There's a direct link in the chat where you can just grab your phone and scan the little QR code here, and that'll take you to the page to sign up for our online viewing session email list. And at most, we might send 8 emails a year, and that's only if we have to postpone every session. So by and large, on an average year, if we never postpone, you'll only receive like 5 emails a year. So it's not like we email you every day with, offers like some email lists and that sort of thing. We use it very sparingly. Or if you can't use the QR code, or the link doesn't work for you, you can just email us at this address, or use our contact form on our website, and you can just ask us to add you to the online viewing session email list. Again, we don't send out a lot of stuff with this. You can join us for our next general meeting, our first event of the new year. Our very special guest will be the Princeton astrophysicist, J. Richard Gott, who is the gentleman that first theorized the large-scale structure of the universe, or the cosmic web. So you know how galaxy clusters are connected to other galaxy clusters in this big web? He's the guy that came up with all that. So he will be our special guest at the Friday, January 10th meeting. You can join us live at the Kalamazoo Area Math and Science Center, or you can join us on Zoom. And I should mention, at the request of the speaker, this will not be posted on YouTube. So no recording on YouTube. If you want to see this talk, you got to join us live, because for his reasons, he did not want it posted on YouTube. So sorry about that, but that's speaker request. So we decided to hold up to that. And so I posted it in the chat. If you are a member or you're on the list already, you already have this link, but here's the link to download tonight's images. Just note it's December 24 OVS.zip. But don't try it now, because obviously we don't have all the images yet. We're taking the last one right now. So I'll probably get those posted tomorrow, but maybe by Monday. So if you can't download the images by Monday evening or on Tuesday, email me and say, hey, where are the images? But odds are I will have them online early tomorrow. But I gotta, I gotta do more than just download them. I do some light processing on them too. So there you go. Let's go back to the browser. See how we're doing. We got a guide star. Now we definitely should get a guide star, because there's certainly lots of stars in the cluster. But this time it'll be guaranteed to be in focus too.
Richard, when you use bulk mail, have you been experiencing problems with bulk BCCs to Gmail users?
Yes, I have. I stopped doing that. That's why I moved the online viewing session email list to MailChimp, because you can't send too many you can't send too many emails at once to Gmail, otherwise it rejects them. Other servers have done that too, and so many emails got rejected. I just gave up on it.
I only learned about it on Thursday, and I'm running a weight loss initiative January through March, and I had about 10 or 12 Gmails. I sent them all separately.
Yeah.
I only had 40 odd people taking part, so it wasn't a big deal, but it's a nuisance. I keep interfering.
So we were imaging way up here, right about there. In fact, if let's try to zip to the full resolution version there. I can't quite. I don't think that's it. It should be more up here, I think. So I can't quite make it out on the all sky camera. but that's not too surprising. But we're looking pretty high on this one. In fact, the altitude is 78.7 degrees, so not quite at the zenith, but pretty darn close. Almost done there. At least it's guaranteed to be in focus.
We shall see.
Should have some nifty star spikes. There we go. Okay, now everyone knows the routine by now, has to count stars. 7,714 image stars found. Oh, I wish I could count that fast. Counting stars.
How's it differentiating for catalog stars?
It knows the aperture and focal length if I put it in correctly, which I did, and then it knows the image scale of the camera, and it just matches with a catalog that we downloaded. And hopefully, because we do have to get a new computer out there because we're stuck with Windows 10, and we definitely want to upgrade our computer before Windows 10 loses its servicing. But we'll try to get a faster computer too. All right, are we ready for our last target of the night?
Yep.
M34, the spiral cluster.
Wow, very nice.
Very good. Beautiful. Very
Now,
nice.
Now for this one, let me click there. Oh, dang it. And let me do. There we go. Because I mentioned we had a target. We had they're on the top now. Notice this thing here.
Yeah.
And this thing over here. I thought those were artifacts at first, but those are galaxies.
Oh.
I couldn't figure out which ones though, so make that a project for someone. Figure out what galaxies these are.
Oh, that's nice. Yeah, no, you can maybe possibly do a check on that. I'll look at that, up those.
Sure.
Yeah, this looks even better focused than the other images you took. I wonder if it's because it was closer to the zenith.
That's part of it too. Yeah.
That's terrific. Could have vignette in there, but yeah.
Yep, you can zoom in there a little more, not too much, but again, you'll get the full resolution version here. So yeah, I thought we would end the year with some nice big old sparkly stars.
Beautiful.
So this contains about 400 stars, ranging from 0.12 to 1 solar mass. Assuming the distance of 1,500 light years is correct, its angular diameter of 35 arc minutes translates to a true diameter of about 15 light years. The cluster is 200 to 250 million years old, roughly the age at which stars with half a solar mass enter the main sequence. It takes sun-like stars 30 million years to do that. The metallicity has a value of iron to hydrogen ratio of 0.07, which means this is equivalent to 17% higher proportion of iron compared to the sun. Other elements show a similar abundance, except for nickel, which is underabundant. So if there are planets around some of these stars, they could have very metal-rich planets. Very metal-rich for making civilizations, possibly. Who knows? There's at least 19 member white dwarfs. These are stellar remnants of progenitor stars up to 8 solar masses to die at an age of just 200 to 250 million years. In 2003, 17 out of 94 member stars were resolved as close pairs with separations between 0.09 seconds to 6.4 seconds. So if you do got a good focal length telescope, you might be able to resolve at least some of the close further ones as binaries, but it's unclear how many of these are actually true binaries and not just close by line of sight. It does have a similar proper motion with M44, the beehive cluster, NGC 2516, IC 2602, and MAIL 20. And so they all may form a local association of star clusters. So they all have to seem a similar origin. They're just not bound by gravity. So this is the only association of star clusters I've really ever heard of. So there we go. That's our last target for the night.
Thanks, Richard. That's great.
So thank you for joining us for the December online viewing session. I'll cut things off a little quick here because we're going overtime because of the focus issues that ate up a lot of time. But again, thanks for joining us, and thanks for those of you that stuck with us through the technical glitches. And hopefully we'll see you at the January general meeting and definitely at the January online viewing session. So thanks again for joining us, and happy holidays.